morning, students. Again, this is Miss Codner. This is for the lesson of March the 15th and the 16th. So today I'm going to collect the homework, which was the last 4 problems that we did last time. And then we're going to do a continuation of our notes on exponents. So after I collect, or while I'm collecting the homework, you have a drill. So you have problems 1, which is 2x to the third times 4xy squared. Number 2, which is negative 7x squared y times 3y cubed y to the second. Number 3, 5bc to the third d, and that's all being raised to the second power. And number 4 was 1/3 times 2a cubed b times 6b cubed. And one of the things I wanted to do is just to reiterate what we did last time, which is the product of exponents. So looking at those product rules. So if you notice with that 2x cubed for number 1 and that 4xy squared, we're multiplying. Even though they're inside parentheses, those are not considered bases because they're not, meaning what's inside the parenthesis is not being raised to a power. So like this is not being raised to a third power, this is being raised to a fourth power. They're not being raised to a power outside the parentheses, so therefore we're just simply going to go ahead and multiply. So we can do one of two things. We can break it up, meaning I can take those coefficients, that 2 multiplied by that 4, and then I can group my x's, which will give me x cubed times x, and then group my y's, which is just simply the y squared. So from here, all I'm doing is just grouping my coefficients, then grouping my x's, grouping my y's, and now I can just go right into multiplication. So 2 times 4, that gives me my e, and my x is going to be raised to the 4th power because when I'm multiplying, I'm adding the exponents. There is assumed that there is a 1 that's an exponent there. And I'm going to multiply our y squared. So my solution is going to be 8x to the 4th y squared. Doing the same process for number 2. Again, we're multiplying the coefficients. So that's negative 7 times 3. Multiplying my x's, which we have an x squared and we have an x cubed, times my y and my y squared. So when we do the multiplication, we have a negative 21 x to the 5th, y to the 3rd. Okay? So I'm going to switch colors here to show you parts of number 3. So this whole product inside that parenthesis, that is my base. The reason why it's my base because I have it being raised to the second power. So within the parenthesis here, this is my base. And then this is obviously my exponent. So now, everything that base is, I can write it out one of two ways. I could, as I put it out here, say 5bc cubed d, and I'm going to multiply it by itself. And remember that exponent is telling me how many times I'm going to multiply my base. So I could do that and then go ahead and solve. Or I could make sure that everything inside that parenthesis is being raised to the second power, meaning 5 is being raised to the second power, my b is being raised to the second power, my c cubed being raised to the second power, and that d is being raised to the second power. So from here, I'm looking at 5 squared. So 5 squared is not 10. It's not 5 times 2. It's 5 times 5, which gives me an answer of 25. B raised to the second power is b squared. C cubed raised to the second power. Since I have an exponent, a parenthesis, and an exponent, that means I am multiplying my exponents. So that'll be c to the sixth, not the fifth. Okay? And then lastly, my d raised to the second power. Okay? Number 4 was one of the classwork. And a lot of people asked me questions on this one. So that's why I kind of make it into a drill. So now, we're just doing straight across multiplication because none of those parentheses are actually being raised by a exponent. So that means I'm getting my coefficients together. I'm writing my a's together. I only got one of those. And I'm writing down my b's. So now you're probably saying to yourself, how do I figure out 1/3 of 2 times 6? Why don't you just multiply the 2 times 6 first? So that would give you 12. 1/3 of 12. So think about it. 1/3 of 12 is just simply 12 divided by 3, which is 4. Okay? Now looking at my a's, so I have a to the third, because that's the only one I have there. Since I'm multiplying, I'm adding my exponents. So that would give me b to the fourth power. And my solution is there. Okay? So I did write up another one just to make sure that everybody understood that little part. So again, I have my 1/2 times my 8 times my 2. Then I get my A's. So the way I organize it is basically I think about the alphabet. A's, then my B's, then my C's. So now I go a to the fourth times a times b to the third times c cubed times c to the fourth. So now, first things first, I want to combine 8 times 2. 8 times 2 is 16. And then 1/2 times 16 is just basically 8. Now, a to the fourth times a, that will give me a to the fifth. B times b cubed will give me b to the fourth. C cubed times c to the fourth will give me c to the seventh. So the main thing to wonder about is when you are dealing with the product rules. When you're multiplying, just like how we just did for this problem, when we're multiplying like this, we are adding these exponents. Okay? So when you're multiplying with same bases, you're adding the exponents. So after the warm-up, we went right back into that Khan Academy. And after listening to the last one, it was really hard to hear everything that was going on. But again, you can go to the website, click under Materials and Study Skills, scroll all the way down to the additional resource websites, click on Khan Academy, and then in that search engine, you type in the exponents. But this time we're going to be involving with the quotients. So I know it's going to be hard to hear it, but that's how you would go through it. My suggestion, pause this and then go to that website and look at how he's doing his steps, okay? But I will do this just for right now. I'm going to pull a couple of his examples on the next page of my site just to reiterate what he was instructing, okay? So one of the examples he mentioned was 5 to the 6th power over 5 to the 2nd power. So remember, quotient is just another name for division. So in this situation, 5 to the 6th power, that's telling me I'm multiplying that base of 5 6 times. And then its denominator, I'm multiplying that base of 5 2 times. So if I went ahead and did the division, that means I have this 5 divided by this 5, and that would give me an answer of 1. So they could automatically cancel each other out. Same thing goes for this one. So I have 5 divided by 5. They can automatically cancel out. So now, take a look. What's left over? What's left over is 4 of those 5s, those base 5s. So that means my solution should be 5 to the 4th power. Okay? Let's try it again with 6 to the 7th over 6 to the 3rd. So this is telling me I'm multiplying that base of 6 7 times. And then in the denominator, I'm multiplying this base of 6 3 times. So just like we mentioned before, let's go ahead and do the division. So 6 divided by 6 will give me 1. 6 divided by 6 will give me 1. 6 divided by 6 will give me 1. So right now, in reality, my denominator is really a 1. Because if I said 1 times 1 times 1, that will give me a solution of 1. But how many 6's are left? Hopefully you said 4 of them. So we can say 6 to the 4th power. If you wrote 6 to the 4th power over 1, remember, anything divided by 1 is going to be itself. So I can leave it as 6 to the 4th. So now, what's the situation? What's actually going on here? What will be the shortcut? So if I refer back to the first one, if I started out with 5 to the 6th power divided by 5 squared, I would get an answer of 5 to the 4th. What's actually occurring? To me, it seems like if I have the same bases and I'm dividing, I'm actually subtracting my exponents. Let's see if that works for this one. So I had 6 to the 7th divided by 6 to the 3rd. 7 minus 3, that'll give me 4. Isn't this the same as what we just got? Yes, it is. So the key right here is when you're dividing, you are actually subtracting your exponents. Okay? So unlike what last time, if I use 5 to the 6th times 5 to the 4th, when I'm multiplying, I'm actually going to add my exponents when they have the same base, which in this case will give me 5 to the 10th. But when I'm dividing, I'm only dividing the exponents that have the same base. Okay? So let's give this last one a try. So with this last one, I have 3 to the 4th divided by 3 to the 10th. So now we have the same base. We are dividing. That means we're going to have, if I do it the extended way, I have this base of 3 being multiplied by itself 4 times. And then we have that base of 3 in the denominator multiplying itself by 3 times. I think that's 3. I mean 10 times. Okay. So what happens here? These 3's cancel out, those cancel out, those cancel out, those cancel out. How many 3's, how many base of 3's are left over? Hopefully you said 6 of them. But where are they located? They're located on my denominator. So what's left over in my numerator is 1. Remember, we got 1 is now to 1 times 1 times 1 times 1. 1 times 1 is 1 times 1 is 1 times 1 is 1. So we still have an answer of 1. But what's left over is 3 to the 6th power. If we went with our principles earlier and we said 3 to the 4th minus 3 to the 10th, that should give me an answer of 3 to the negative 6. So you're probably saying to yourself, well, which one's the answer? To be honest with you, both of them are the answer, are the correct answer. They're interchangeable. The one thing that you need to know, especially with exponents, you never, ever, ever want to leave your exponent as a negative. So in order for us to do this, you have to do what's called the reciprocal, okay? And I'm going to show you examples of that. So first things first, here's the rules when we're dealing with quotients. So when you have a number being raised to a power divided by that same number, that same base being raised to a power, you're actually going to subtract the exponents. So that's what that first one's telling me. X raised to the A divided by X raised to the B, you're actually going to subtract those exponents. And you're going to subtract them from the top, which is your numerator, by the bottom. Okay, you start at the top minus the bottom. And then the second one is just reiterating what we also showed when we did products. So when you have that fraction, that whole thing inside that parenthesis, everything has to be raised by that power. So if you had x over y in the parentheses and that whole quotient is being raised to a power, that means x has to be raised to that power of a, and that y has to be raised to that power of a. Negative exponents. Every time you get a negative exponent, you're going to take that exponent, take that whole power, and you're going to put a 1 over it. And it's going to change that exponent from a negative to a positive. So for example, if I had 3x raised to the negative 4th. So now, you're saying we have a negative exponent of 4. So what is actually being raised to that negative 4th power? Is it the 3, or is it the x, or is it both? Hopefully you said just the x, because it's not inside of a parenthesis. So what we're going to have to do, this is what's going to have to do the reciprocal. So if I could rewrite it, I would rewrite this as 3 times 1 over x to the 4th. Because every time you have a negative reciprocal, it's actually going to drop down into the denominator. And just that action of dropping it into the denominator is going to change that sign from positive to negative. So now you could leave it like this, but we need to simplify. We need to clean it up a bit. So this whole number of 3 is also seen as it being over 1. And when we multiply fractions, we multiply the numerators, which will give me 3, over the multiplication of the denominators, which will give me x to the 4th. So this right here is going to be my solution. Let's say I had, let me bring it over here. Let's say I had in parentheses 3x raised to, I like 3's today, raised to the negative square. So now what's actually being raised to the negative power? That entire base of 3x's. So that means that whole entire thing is going to be over that 1. So we have 1 over 3x let me continue with the parentheses, but instead of a negative 2, it's going to be a positive square. So now we did the flipping, let's do the solving. It's still going to be underneath 1, but what's 3 squared? Because remember, we're going to have to distribute that square to everything inside that parenthesis, meaning that 3 is going to be squared and that x is going to be squared. So that means we have 1 over 9x squared. And that will be my solution. Okay? So when you have a negative exponent, you got to drop it down in that denominator. Okay? Whatever it is. Last few examples before we had some classwork. So, example number 1 is telling me the quotient of 2x squared over 3 is being raised to the 4th power. So first things first, when you're solving these, now we're going to do some bit of combination of products, and we're also going to do some combination of the quotient rules. When you deal with these, always remember this, please excuse my dear Aunt Sally. So we're constantly thinking about order of operations. So first things first, inside this parenthesis, is there anything inside there that we can simplify? Right now, we can't do anything with the 2/3 because it'll just give me a decimal. There's no other x's except for that x squared, so there's nothing to do inside the parenthesis. So that means I need to distribute that 4th root, or that raised to the 4th power, to everything inside that parenthesis. That means that 2 has to be raised to the 4th power. This x squared has to be raised to the 4th power. And that 3 has to be raised to the 4th power. So, 2 to the 4th power is 16, not 8. And x squared raised to the 4th power will be x to the 8th. Remember, when it's an exponent, a parenthesis, and an exponent, you're multiplying your exponents. And then 3 raised to the 4th power is not 12. This is the same as saying 3 times 3 times 3 times 3. Last time I checked, 3 times 3 would give me 9. And 2 9s will give me 81. That's my solution. For number 2, we're doing the division. So you have 6 divided by 3, which gives you 2. You have x to the 1st power divided by x to the 4th power, which will give me x to the negative 3rd power. Okay? And then my y's, y to the 3rd minus y to the 1st, will give me y squared. Is this my answer? No, it's not. Because I have a negative exponent right here with just the x's. So that means that x to the 3rd power now has to drop down in my denominator. So as a result, we will keep the 2 and we will keep the y squared in my numerator. Now, that x cubed is going to drop down in my denominator. That is my answer. So anything with a negative exponent, when you solve it, it automatically drops down into the denominator. Everything else will stay above it. Okay? And this last one, oops. Okay, so what I've noticed when we were doing this, a lot of people said, okay, I have negative 10 divided by 2. That means I got to subtract this, so I should get a negative 12. No. The only thing that you're subtracting are the exponents. These whole numbers right here, you're still dividing those. Either you're dividing them or you're simplifying them, almost like fractions, okay? So if you have a negative 10 divided by 2, that would give me a negative 5. A to the third divided by A to the eighth, that will give me A to the negative fifth. B to the third divided by B to the ninth, we're subtracting those exponents. That's why I have it raised to the negative 6. C to the seventh, C to the 10th, we're subtracting the exponents. That's why it's a negative 3. Remember, you go from the top to the bottom. And now you have D divided by D. Remember, their exponents are 1s, right? So 1 minus 1 is 0. This is a continuation of what we talked about last time. D to the 0 power. So anything to the 0 power is what? Is 1. So we don't need to write that one down because since we're doing multiplication, you'll just have negative 5 times 1, which gives you a negative 5. So what do you notice? My A, my B, and my C all have negative exponents. So that means all three of them are going to drop down. But what's going to stay on top? My negative 5 is. Okay? Negative 5 is not an exponent. Oops, that's really positive 6. Okay? That negative 5, that's not an exponent. That's a coefficient. The coefficients will stay as is. Okay? You're only moving around those with negative exponents. All right? So after we did that, we worked on our class notes, okay, which is that tan sheet. And for homework, they continued that tan sheet. All right? So if any questions, any concerns, just go right to the can or replay this. And I'll talk to you later. Bye.